Alright, we are back with another structural analysis video today. This is a statics review problem. Again, reactions are the first step of almost every problem you're going to see in structural analysis, and something you should have learned in statics, but it's always good to review. So, we have a frame here, and we have a hinge at A, we have a roller up here at B, alright, and this connection right here, anytime you see something like that, or something like that, that means this is a rigid connection, so it's resisting moment, as opposed to something like that, which is not resisting moment, okay, which would be a hinge. Okay, so for this one, we're saying that that is resisting moment, so there will be a moment, internal moment being applied within, or occurring within that member right there. Alright, so let's go ahead and let's look at this, which doesn't really matter for this one, but when you get into drawing shear moment diagrams for frames, that's when it does become an issue. But for this one, we just get to consider that a rigid piece. Okay, so this is one giant frame. Not giant frame, but a frame. Alright, so first things first, let's go ahead and find some resultant loads here, right? We have a W load of 4 kips per foot. So the area under this curve is its resultant load. If you think of this 4 kips per foot as its height, this is its length. Well, what is its length? Well, we need to determine that. We need to use a little bit of trig. We know that we have a triangle. Okay, and this is, we can call this point C. Oops, it didn't show up. Point C. This is A to C, right? We know that this is 15 feet right here, and then we know that the height is 15 feet, okay? So we also know that this is at 45 degrees, right? So we can say A to C is going to equal to the square root of 15 squared plus 15 squared. So 15 squared plus 15 squared, square root that. 15 square root of 2, let's convert that as 21.21 feet. Let me come over here, I'm going to add that. 21.21 feet. Okay, so our resultant then, which we need for some of the moments, right? That's why we find the resultant is for some of the moments, is going to be, so our R1 is going to equal 4 kips per foot times 21.21 feet, right? With our feet canceling out. So that number times 4 is 84.85 kips. All right, let's do the exact same thing with the red load. We have 3 kips per foot. It's going to have a resultant directly in the middle, right? So what we could have done up here is 21.21 divided by 2. This is 10.6. 10.6. Oh, we go 10.61 feet. That's to that resultant. And then up here we have 15 plus 10, that's 25. So this distance right here has to be 12.5. Right, we're going to the centroid of that area, which is just a rectangle, which is 3 kips per foot times 25 feet. It's equal to 75 kips. Feet cancel out, we're left with 75 kips at 12.5 from C. Alright, well, what do we have going on at our supports? B is a roller, so we have R, B, Y. Over here at A, we have a hinge, so we have R, A, Y. And we have R, A, X. Now, I just took a glance at this, and I know that this has an x component going to the right. That's the only x component that's out there, so my RAX has to be going to the left. Okay? But if you pick those arrows going in the wrong direction, when you do some of the forces in the x or some of the forces in the y, you'll just get a negative number. Now a negative number always means that the direction you assumed it was going is wrong. Okay, so a negative number does not always associate with it's going to the left, right? A positive does not always associate with it's going to the right. The negative number means that whatever answer you got, it's the opposite of that. Same thing when you're doing method of joints, right? If you assume that a member is in compression and you end up getting a negative value, that means that it's actually in tension. So although we relate negative to compression and positive to tension, when you're dealing with your sum of your forces in the x and y direction, that negative only means that it's going the opposite of what you had anticipated or what you had noted. All right? So the negatives can be tricky, but you have to, know how to deal with them. Okay. So let's start with sum of forces in the x. So let's break this guy down. I'll do it over here. All right, so we have this force going here of 84.85. It kind of looks like a 9. That's a 4. Okay, 84.85. And it has an x component and it has a y component. And it's at 45 degrees, which means that they are the same. So cosine of 45 degrees is equal to adjacent over hypotenuse. Our hypotenuse is 84.85. So therefore, A is equal to 84.85 cosine of 45. So 84.85 times 7.07. 84.85 times cosine of 45. 84.85 times cosine of 45 is equal to 59.99, which is equal to about 60 kips. Okay, so that means that this is 60 kips and this is 60 kips. Now we can check that too. So 60 squared plus 60 squared, 60 squared plus 60 squared, oh my gosh, squared plus 60 squared, square root that, 84.85. So we know that that's correct. Okay. So we can do sum of the forces in the x direction is equal to 0. It's equal to negative RAX because I have it drawn going to the left, plus 60 kips. Right? Rearrange, RAX is equal to 60 kips. Okay, that's one reaction down. Alright, now we need to do the sum of forces in the y. But if we do sum of the forces in the y, we have one unknown, we have two unknowns. I'm actually going to go straight to sum of the moments. So let's do, switch colors here. Sum of the moments, let's do about A. And I'm putting the symbol here representing that counterclockwise rotation. I'm saying is positive. It doesn't matter. It just matters of like what you're saying is one way is positive, the other way is negative. I'm saying this one is positive. Some books, textbooks, even the textbook I use, it goes the other direction. It's just however you're using to solve it. So it's not really a make or break thing. Okay, it's just as long as you know that if you get a negative answer for this one, it just means that your thing's going the opposite direction that you thought it was rotating. So this is equal to 0, right? If I hold my finger at A and I apply this load, it's going to cause a positive or a negative rotation, a clockwise rotation. Now typically when we have these things at an angle, we break it into an X and we break it into a Y. Okay, but for this one, the perpendicular distance of this load is easily found. We already found it. It's 10.61. So we're going to say negative 10.61 times 84.85. And I'll prove that to you in a second that it does work. Or how you could do it the other way. Alright, then we also have causing negative rotation, a 75. So minus 75 times what's its distance? Perpendicular distance. If that force is in the y direction, your perpendicular distance has to be in the x direction. So we have 15 plus 12.5. So we have times 27.5. Right? 15 plus 10 is 25. 25 plus 2.5 is 27.5. All right, and then we have RBY. Again, if you hold your finger here and you push on RBY, it's causing positive rotation. So plus RBY times, well, what is its perpendicular distance? It's in the x direction, and it's going to be 15 plus 15, which is 30. All right, so let's rearrange this. These are negative, so I'm going to move them over to the other side. So we have 10.61 times 84.85. This is 900.26 plus 75 times 27.5, 2062.5 is all divided by 30 gives you RBY. So that plus that divided by 30, RBY is equal to 98.76 kicks. All right, so it's hard to kind of tell on this one what you would automatically think of as going to be larger. Sometimes it's really obvious. Right? Like if this blue load wasn't here, I would say that this B would be much larger. Okay, I can't really tell on this one off the top of my head if that's entirely true. I think they're probably going to be, I don't know. Sometimes it's easy to tell, sometimes you have a sting test, sometimes you don't. On this one, I don't really know. But we can go now to some of the forces. Well, let me show you, I do want to show you this. So, some of the moments about A is equal to, we could have broken this one up. Right, so this was 60, when this was 60, and they're going to be at half of 15, 7.5. So if we look at this one, these are both causing negative rotation. So we would have negative 60 times 7.5, and then we'd have minus 60 times 7.5. There'd be more steps, but I just want to check this really quick. So 60 times 7.5 plus 60 times 7.5, you get 900, which is what you got up here, basically. So up here you had 926. Down here, that's because I rounded the 60. Okay, we also get 900. Okay, so this would continue on. I'm just saying you can break it up however you want, but if your force is given to you on a surface that gives you the perpendicular distance, you don't have to break that up. The only reason you have to break this up is for some of the force in the x and some forces in the y. Okay, so let's move on to, let's solve AY two different ways so that we can prove it to ourselves. So let's do some of the moments about B. Again, counterclockwise is positive. Well, if we're rotating about B, this is going to be positive, so we're going to have this is equal to 0 is equal to positive 75 times, well, what is this distance right here? It's 2.5. Okay, and then we have positive, this is where you would need to break it up, right? You don't necessarily have a perpendicular distance staring at you for this one, right? This perpendicular distance would be this distance right here. You extended this down, right? You have to do some trig to figure this out. So I'm glad we have those broken up. So now I'm going to say, let's go with this horizontal one first. We have plus 60 times, well, that one's simple. That's times 7.5, right? Plus, we have this vertical one. We have 60 times, well, what's its perpendicular distance? Its perpendicular distance is 7.5 plus 15. Okay, so 7.5 plus 15 is 22.5. All right, and then we have minus RAY times 15. So we can rearrange, we'll move the RA over to the other side. So we have RAY is equal to, well, we have 75 times 2.5 plus 60 times 7.5. There's a point there. Plus 60 times 22.5. So this is 1987.5 all divided by 30. I get 66.25. But I don't know if that is the right answer. So let's check. We might have missed something up there. Let's see here. Sum of forces in the y is equal to 0. Well, we have RAY minus 60 minus 75 plus 98.76. So RAY is equal to 60 plus 75 minus 98.76. I get RAY is equal to 36.24. Alright, well what did we mess up over here? Because these should be the same answer. So let's look at this. We have 75 causing positive rotation, and it is 2.5 away from RBY. 75, 2.5. Let's just make sure I put it in my calculator right before I go any further. Times 2.5. Okay, plus 60 times 7.5 plus 60 times 22.5, 198.5 divided by 30. Yep, so something's wrong here. So we have 75 times 2.5. I feel good about that one. All right, we have 60 causing positive rotation times 7.5, which is this height. Yep, I like that one. Then we have a 60 going down, and we have 15 plus 7.5. Well, I did that in my head. Let's do that again. 15 plus 7.5 is 22.5. Also, why do I have a 15 written over here? This is definitely supposed to be a 30, which is fine because I did that down there. So what am I missing? 60 times 7.5. 60 times 7.5 plus 15 minus 75 times 2.5. Ah! That's what we're missing. We have the RAX. What is our RAX equal to? It's equal to 60. That's a huge one. There we go. See, we solved our problem. That's causing negative rotation. So up here we also have minus 60 times 15. Okay. So, what do we have here? So we have 75 times 2.5 plus 60 times 7.5 plus 60 times 22.5 minus 60 times 15. So this gives me 1087.5 divided by 30, 36.25. Okay, so easy mistake to have made, right? But I think it's important to see that you have ways of checking your answers. All right, so if you question your abilities, right, or you're me, and you're going to make simple mistakes, right, you need to have backups to check your answers. So I knew that I had two options to solve for RAY, and when I got two different answers, I could then go back and say, okay, what was I missing on that rotation, right? And it's important because if you get RAY wrong, if you get RBY wrong, So say you did your sum of your moments about A and you did this incorrectly, and then you just plug that number in here, and you blindly believe it, and then you plug in and you solve for RAY, and you just walk away from that problem, then there's something off there. You need to prove to yourself that this answer is correct by proving that this answer is correct, by proving that this answer is correct. Now I get on exams, you gotta move fast, okay, so you might not always have time for that, but this is a great way to make sure that you don't make a dumb mistake like I just made. Alright, so that's all I have for that one. We have RAY, we proved it 2 different ways, which confirms that our RBY is also correct, and RAX is equal to 60. Alright, that's all I got.